Hello ladies and gentlemen, what's up? It's Papa Bale and welcome to the channel. So from my live stream that I did recently till now, I've now hooked up that same system on this one battery. We've closed looped it to see how close we actually are to unity or over unity. Either one would be nice. But we are just using a pancake coil and a signal generator. This is the cool part about it right now, though. We're using 113 hertz. So 111 kilohertz plus 113 hertz. We got tremendous amounts of speed for how much hertz that is, and so we're putting that plus 1240 is what the battery's at. So we're putting 1240 in. We're putting in 110 kilohertz to this pancake coil, and then we are running this motor. You can see the light flashing a little bit, the red lights. If you focus, they're blinking, and that means we're spending in genning. There's definitely a discrepancy there. Not so much here though. But this is coming. This is all good. How do I explain this? So it goes from the battery, and we're at a lost cycle right now. So maybe we need to up the hertz, but that took a while. So we're not to over unity or unity just yet. But okay, so the meter over here is the DC output of this cap bank over here, and this cap bank is hooked up to the coil. The AC side is hooked up to the coil. So the energy coming off the coil and going to the other side to run the motor is 6 volt, 6.92 DC volts is what that is right there. So for 12 volt 3.9 input, I'd say we're still pretty far away from where we need to be. There we go. See, so I get down, we're up around 100 kilohertz right now. And, we get about 7. So if we drop it, let's drop it to 100 to start. We get to like 731, right? 732. Let's drop it to 80. Well, 90 first. You can see that that's steadily going up. The voltage output. Here we go. We've reached a plateau. So we'll go to 85 kilohertz. We got 8 volts. See, and it sticks around the 100th for a while. It's like it's hard to tell whether you're doing the right thing. But this output is going up. The speed of the rotor is going up. This is staying the same, but I know it's going down. 85 kilohertz. Go 80. 80 kilohertz. 8.5 volts now. But I think we're starting to spend a little bit more than we're genning. Let's take a look at the DC amp output. It's 150 milliamps. That's not bad. So we'll go to 75 kilohertz. We're generating 159 now. Wow. It's actually pretty good for just, what I'm doing here. 75. Looks like a good number. Let's see here. 76. 75. Almost 160. That's brilliant. But You know, we're at 1238 now. But we got the most amps that we can get, I believe, is going to be right around 160 milliamps. And this is almost 9. Everything's running smoothly, man. It's not getting hot. It's pretty nice. Like consistent temperature. The coil is, anyway. It's so hard to see how much we're actually spending. I don't have a meter that will tell that to me. Let me think. Let me think. So we're going in here. I'm trying to think of where I connect the multimeter to see how much amps we're spending. So I would say you would connect it where you're spending. That's right here. So I would connect it to the collector and the emitter, because I want to see how much is not going into the coil but going into the transistor, since I have the power going into the transistor first. So the power going into the transistor first means that the power is going to be spent there prior to it entering the coil or amplified or whatever's going to happen there. See, so the inside of that is spherical, so it's supposed to house a neodymium 1.26 inch spherical magnet at N52 strength. But it's a little off. It's off by like a millimeter, or like 3.03, maybe 0.03 millimeters. It needs to be a little bigger. And then I want it to be able to move around in there a little bit. Just a little bit though, you know? Oh, we're increasing right now. This meter right here is going up. So I don't know what that means in the grand scheme of things, but we are definitely going to be picking up in speed on the rotor because that's going up. Will it maintain an upward advancement? I don't know. We'll have to see. But this dig is going down again. 1238 though. That's where we're at. And this is going up to 8.9. And we're 75 kilohertz in the Pancake Coil. We're trying to reduce our milliamp spending up to less than 160, less than 150. See, we're making 159 milliamps at 75 kilohertz. So if we're spending less than that to run this motor, we win. That's a win. That's over Unity using what I have on me. You know, what I have, instead of getting what I quote unquote need, I use what I have to accomplish the same goal. I mean, I'd love to have the money to just get what I need. I'd love to have a Jarvis to just print me out what I freaking need when I need it. That would be awesome. That'd be too dope, man. That'd be fly. But it looks like we're kind of in a flux period here. We're in between 8.90 and 8.91. In the output, the DC output for the Pancake Coil, we're 12.37 volts in, we're 8.9 DC volts out to run the motor. But what's coming out of the motor is right here, and we should figure out what that is. I'll be right back. So I did manage to get our milliamp output to 215. And that's right before we dump it into the battery. So 215 is our dump rate. And we're still going down though. So maybe I have something hooked up backwards or something, I don't know. But it's 215, 214 milliamps being generated. Closed loop system. So we got our pancake coil that's being pulsed at 111 kilohertz. 888 hertz dot 88. So it's 111 888.88. I'm not going to say that. 111,888.88. There you go. And I don't know if there is a magic number to do this, especially, well, I like that amp reading coming off the motor. That's pretty cool. All right, and that's how much voltage. Nice. It's going up, or it was going up. 11.15. That's beautiful. See, we can make the voltage go up, but the amps, I believe, are going down now. But we will check it out real quick before I end the video. Okay, 100 kilohertz, and we're at 11.959. That's where we're going to stay, I'm pretty sure. All right, so thank you very much. Peace out. Have a wonderful night. Please subscribe, like, hit the notification bell, and I'll check you later. Peace out.